So you can either have this pulled up and whatever you want, or you can just watch, okay? So we're going to talk about the unit circle today. We're actually going to do the inverse of the unit circle, like kind of going backwards. But we need to remember the unit circle so that we can do all these problems. So let's kind of fill in quadrant one again. It has been a while, so if you go to here, this is pi over 6. This angle to the really dashed line is pi over 4. And then this one to the top is pi over 3. Okay, and at each of these angles, we have points on the unit circle. And for this one, the point here is 1/2 rad 3 over 2. You are required to still know this. I know it's been a little while. This right here is rad 2 over 2, rad 2 over 2. That's my favorite one because they're the same. I can't ever get them mixed up. And then at pi over 6, you have the point rad 3 over 2, 1/2. And when you're evaluating the cosine, sine, tangent, any of the trig functions, when you're evaluating them at the angle, the cosine of theta is the x coordinate and sine of theta is the y coordinate. Okay? So that's all review. That's all stuff you should know. And then don't forget tangent is sine over cosine. So let's go ahead and evaluate. Here we go. So here's the first one. I need to find out what the cosine of pi over 3 is. So I go on my unit circle to pi over 3, and the cosine is what? 1/2. Perfect. Some of you guys were really good at this on that last quiz that you took last Friday, but these are pretty hard sometimes. Okay, I'm just doing quadrant 1 right now because I'm going to explain why today. If you go to the sine of pi over 6, the answer is 1/2 again. Go to pi over 6, out to the y coordinate, it's 1/2. And the tangent of pi over 4 is the sine over the cosine. They're exactly the same, so tangent of pi over 4 is 1. Okay, you feel pretty good? Let's just review. Now, these are working the other way, okay? And this is going to help us with what we're going to do today. So find the angle in quadrant 1 where the sine of theta is equal to 1/2. So I go to quadrant 1, because that's what they told me to do, because this actually has more than one answer, but they told me just to restrict it to quadrant 1. What angle do I have a value of sine of 1/2? Well, look at, yeah, it's the opposite of this question right here. This is saying sine of pi over 6 is 1/2. This is saying sine of what angle gives me 1/2. The answer is pi over 6. This one too. I found it up there. What's this angle? Pi over 3. The cosine of pi over 3 gives me 1/2. We're looking at it a different way. We're trying to find where cosine is 1/2, and then you give me the angle. Tangent is 1. Theta would be, we just did this, pi over 4. Okay. Then they get a little bit trickier. This one is probably the trickiest one. Tangent of theta is rad 3 over 3. I need to figure out what angle gives me this value for tangent. And it's either going to be rad 3 over 2 over 1/2 or the other way. So if y was this and x was that, I could flip this upside down, and this is rad 3. Well, it's not that one, is it? I think you said it already, didn't you, Cassidy? It was pi over 6. Pi over 6. Okay? Some people, they remember it because, watch, if you have the tangent of theta equals rad 3, and the tangent of theta equals rad 3 over 3. For the first one, theta is pi over 3. There's only one 3 here. This one, what does 3 and 3 add up to? 6. So they kind of memorize it that way, which is cute. I don't like memorizing stuff. That's kind of a nice little trick, though, for that one. Okay, what angle gives me a sine value of rad 2 over 2? That would be pi over 4. Perfect. And the last one, where is cosine on our unit circle just in quadrant 1, where is cosine equal to rad 3 over 2? That was pi over 6. Yep, pi over 6. Okay. Excuse me. Now, what are we going to do with all of this? Well, today in our lesson, we are going to do inverse functions, inverse trig functions, okay? So for 7, inverse trig functions, that's going to help us, what we just did in those last problems, going to help us find the inverse trig functions for our 3, and we're only doing 3. We're just doing sine, cosine, and tangent inverse functions. Okay, so let's first do the inverse of sine. The inverse of sine can be written 2 ways. Some people will call it arc sine of x, and it's also sine inverse of x. Remember, that's on our calculator. Have you seen it before? It's right above sine on your calculator. This is not the same thing as cosecant x. Okay? It's not the same thing at all. Sine inverse is the inverse function of sine. Cosecant is the reciprocal of sine. Inverse and reciprocal are not the same thing. All right, so here we go. Now, let's start by graphing the sine wave really quickly, okay? Doesn't have to be perfect. Looks like this. Goes through the origin. Keeps going forever and ever. That's the sine wave, right? This is just simply y equals sine of x. Okay, is the inverse of this function, sine x, is the inverse a function? Who can tell me? Is the inverse a function? Like if I were going to take the inverse of this sine wave, is the inverse a function? The answer would be no. Because why? Do you remember? Yes! The horizontal line test tells us that the inverse of sine is not a function. But what they've done is they've taken sine inverse and they've made it into a function. So what they've done is they've restricted sine so that it can be an inverse when you do this, so that it can be a function when you take the inverse of it. And you're probably super confused, but this is what they do. They're going to stop you here and here. And they want you to just look at this part of the graph in that box. Okay? So let's look at this in the box right here. Where this is still the sine wave. What we're going to do is we're going to take just that section and we're going to find the inverse of that so that when I do have my inverse, it will be a function. Because this right here will pass the horizontal line test. Okay? So if you go to your calculator, I want to show you what the graph of sine inverse looks like. Go to y equals, and we're going to graph sine inverse of x. And then hit zoom trig, and check it out. That's it. Yeah, that's all it is. I'm going to zoom in on it. Okay? What they've done is they've taken this graph right here. Do you remember how to find the inverse of a function? You flip everything over the y equals x diagonal. I'm actually just teaching this in Algebra 2 right now. So to find the inverse of this, you just flip it over, and it actually, probably shouldn't have done it in blue, it's actually just that right there. That's it. That's the inverse graph. Okay? So let's see, -2 to 2. That might be a better idea of it. All right, so now when you evaluate the sine inverse of something, your answers are only coming out of this little teeny box right there. And that's going to be the hardest part about this, okay? So let's talk about sine inverse and its domain and range and stuff. So we have y equals the sine inverse of x. And the domain of this graph, well, if you look at the sine graph, the domain that I'm restricting it to is -pi/2 to pi/2. And the range is -1 to 1. So you know inverses, they switch x and y. So the domain is going to be -1 to 1. And the range is going to be -pi/2 to pi/2. And that's it. Okay? So I'm going to try and make this simple for you. Okay? When you take the sine inverse of something, what you're doing really is you're saying what angle gives me a value. Yeah. No, I switched them. So for sine inverse, yeah. So you're right for sine. So for sine, it's between negative pi over 2 and pi over 2 for x. So I switched that to the y. Yeah, so everything got switched. Okay. So when you give me an answer, when we evaluate the sine inverse of something, you're going to have your answer is going to either be in quadrant 1. Okay. Your answer is going to be a positive angle going into quadrant 1. Or your answer will be in quadrant 4, but your answer will be a negative angle. You're not going to have an answer coming out of quadrant 3 or 2, okay? And your answer for quadrant 4 is not going to go all the way around. You're either going to go up to pi over 2 or down to negative pi over 2. So let's do some and I'll show you what I mean, okay? All right, so here we go. Number 1. We want to find the arc sine or the sine inverse. Those are the same thing, okay? We want to find the arc sine of 1/2. Now what does that mean, arc sine? This is what it means. We're going to try and find the sine of what angle gives me 1/2. We're working backwards. Arc sine is the inverse, okay? Normally I say, what's the sine of pi over 3? And you tell me. This is, what's the arc sine of 1/2? You tell me the angle. So what is the angle here? So you need to go to your unit circle. Do you have your unit circle right there?
Pi over 6.
Yes. Yes. Pi over 6. Perfect. Maybe we should write the unit circle down real quickly on your paper so you have it right there. All right. So we did this up earlier in that little notes, but this right here is 1/2 rad 3 over 2. This is rad 2 over 2, rad 2 over 2, and this is rad 3 over 2, 1/2. Okay? And then we can fill our angles in. This is pi over 3. This one is pi over 4, and pi over 6 here. So when I went here and I said, okay, what is the arc sine of 1/2? I go to my unit circle, I go to quadrant 1, and I get that the answer is 1/2. Now, you might be thinking, maybe, I don't know, that over here at 5 pi over 6, the answer to sine is also 1/2. So how come I only get this answer? I don't get this answer. This answer is off limits. This answer doesn't exist in arc sine, okay? We're only in from negative pi over 2 to pi over 2. That's it. You can't go over there. Your answers are only going to come out of quadrant 1 or quadrant 4, okay? So let's do some more. Number 2. Okay, let's find the sine inverse of rad 2 over 2, and I want to find the sine inverse of negative rad 2 over 2. And I want to show you what the answer to both of these are. So it's a function. What that means is something comes in and one output comes out. I can't have two answers for these. That's why it's limited to just that little box there. So what angle gives me a value of rad 2 over 2? Pi over 4. Perfect. Okay. You're going to be very comfortable with quadrant 1. Anytime you're taking the sine inverse of a positive number, you get something in quadrant 1. Now here comes the tricky part. What's the answer to the sine inverse negative rad 2 over 2? Anyone want to take a guess? It's going to be in quadrant 4. The answer is going to be negative pi over 4. Okay? It's not going to be 7 pi over 4. You're not allowed to do that. 7 pi over 4 is not in the range. It's kind of like this. The range is negative pi over 2 to pi over 2. If I tell you, pick a number between 0 and 10, and you tell me 40, right? You're wrong. Okay? If I tell you the answers are only from negative pi over 2 to pi over 2, and you tell me 7 pi over 2 or whatever, 7 pi over 4, your answer's wrong because it's not landing in that range. Those are the only options for your answers. So let's try this one, number 3. Let's find the sine inverse of rad 3 over 2, and then we'll find the sine inverse of negative rad 3 over 2. Okay? And then you'll get used to it, and you'll be like, oh, this isn't so bad. At first, it's like, what in the world is this, right? But you'll get used to it. So what angle gives me a value on my unit circle of rad 3 over 2 for sine? Pi over 3. Perfect. Pi over 3. And what's this one? Negative pi over 3. And you're asking yourself, is it always going to be opposite? It is. Yep, it is. Okay, let's do one more of these. Let's do sine inverse of pi over, no, not pi over 2. Sorry. Sine inverse of negative 1. And let's do sine inverse of positive 1 also. Okay, where on the unit circle do I get a value for sine of negative 1? Negative pi over, you're close. It's going to be negative, you know that. I heard it. Ricky, did you say it? It's down here. This point is 0, negative 1. Okay. So negative pi over 2. And then the sine inverse of positive 1 would be up here at this point, which is 0, 1. So that would be positive pi over 2. Remember, your answers are going to be between negative pi over 2 and pi over 2, and including those. That's why I put brackets around them for your range, your outputs of values. All right. Okay. By the way, you can't evaluate anything past negative 1 or positive 1. Okay? Your domain's restricted. So if I ask you what's the sine inverse of 2, there's nothing. You can't do that. But I'm not going to do that to you. I'm going to give you stuff that you can. All right. So you're probably like, okay, this isn't so bad. But then we switch over to arc cosine. Arc cosine is going to have its own quadrants that are allowed to be used. Arc cosine of x, which is also called cosine inverse of x. Cosine inverse of x, remember it's not the reciprocal. Cosine inverse of x is really the same thing as cosine of what angle gives me x. That's really what it means, okay? Now, as you know, the cosine graph is different. It's a lot like the sine graph, but it's also different. And it goes like this. So if I were to take that graph and restrict the same area that I did from negative pi over 2 to pi over 2, don't draw this, but I'll show you, will my inverse of that be a function? No, it's not going to pass the horizontal line test in there. Bless you. So I have to use a totally different area. So what area am I going to use? You're probably seeing it. You're going to go from here to there. Okay? So that it's this part right there. And that's going to be cosine inverse when you reflect it over the y-axis, or y equals x. Okay? So what is this and what is that? This is 0, and this is pi. Okay? So cosine inverse, so y equals cosine inverse is going to have the same domain, negative 1 to 1. See, the range is still negative 1 to 1, and we switch that for domain. But the range is now going to be 0 to pi. Okay? So when I'm evaluating what's the cosine inverse of something, I'm going to use quadrant 1 and 2. When the number that I'm doing is positive, I will be in quadrant 1. When the number that I'm evaluating is negative, I will be in quadrant 2. And you can probably see, why couldn't I go into quadrant 4? Because cosine's positive in quadrant 4, so I would get the same answer, and you can't have that. You're only getting one of these because it's a function. So let's evaluate some. What number am I on? Anybody? 5. Okay. Number 5. Here we go. let's evaluate the cosine inverse of rad 2 over 2 and the cosine inverse of negative rad 2 over 2. So the positive isn't so bad. Everyone knows we're going to be in quadrant 1 no matter what for positive. The negative one is a little trickier because you got to think, okay, cosine now. All right, so this answer, the first one, I hope that you can get this pretty quickly right now. Pi over 4. Perfect. So what angle gives me a value of rad 2 over 2 for cosine? That would be pi over 4. Now, where do I get a negative rad 2 over 2? 3 pi over 4, exactly. Okay, so pi over 4, and then over here is 3 pi over 4. Cosine is negative over here. This is negative rad 2 over 2, positive rad 2 over 2. Okay, so anytime you are evaluating a negative number, this answer for cosine inverse will be in quadrant 2. That's what makes it tricky too, because sine wasn't like that. Sine's in quadrant 4 and 1. Cosine's in quadrant 1 and 2. All right, you want to try? You try this one all by yourself. Cosine inverse of 1/2 and cosine inverse of negative 1/2. Try this on your own. Let's see if you understand this lesson a little bit. See if you can get those. We're doing all of these by hand, by the way. No calculator. Okay, so you go to the unit circle, and what angle gives me a cosine value of 1/2? Pi over 3. Perfect. All right, so then I go to the unit circle, and in quadrant 2 is my only option for an answer. What gives me a cosine of negative 1/2? 2 pi over 3. Very good. 2 pi over 3. Okay, are you wondering now, like, how many more of these do you have to go? Just one more. Now we got to figure out arctan. Arctan of x, okay? Which is also tan inverse. And so if you think about the graph of tangent, the graph of tangent goes through the origin, and then it repeats itself over and over and over. So obviously, the inverse of tangent is not a function until we restrict our area that we need to work with. So we're going to restrict it to just one of these guys. That one right there. Okay? So if I want to talk about the domain and the range of arctangent, it's a little bit different. First of all, let's look at this, and what would the domain of tangent be when I'm restricting it from here to here? Negative pi over 2 to pi over 2. That's where your asymptotes are. That's going to be our range. Oh, I saw that one before. Yeah, arcsine and arctangent are going to have the same range. What's the domain, though? All real numbers.
Isn't it the other way around?
Yes, it is for tangent, but you got to switch them because it's inverse. I know, yeah. So the range is all real numbers, so now it becomes the domain is all real numbers. And here, the domain is negative pi over 2 to pi over 2, becomes the range. So arctangent is also going to be in quadrant 4 for your negative answers and quadrant 1 for your positive answers. That would be this part right here, okay? It's just like arcsine. So you're either going this way or that way. And it's actually not that bad. You're like, sure. All right, number 7. Let's try some arctans. Number 7. Let's do the tan inverse of rad 3 and the tan inverse of negative rad 3. All right, so these are a little trickier because you got to think, okay, where does tangent, but I gave you that little trick, right? Where is tangent equal to rad 3? That's going to be at pi over 3, only 1 3. Okay? And then where would it be negative rad 3? Yeah, you just change your answer to negative. Negative pi over 3. Okay? Do one more of these guys. Tan inverse of, 0. Tan inverse of 0. So here's how I go about this problem. I know that my answer is going to be from here to here. And I need to find out what angle is giving me a y over an x where the y is 0 and the x is 1. Where is that? That's right here, right? At the point 1, 0. What angle is that? 0. 0 radians. Don't say 2 pi. 2 pi is not in our range of negative pi over 2 to pi over 2. The answer is 0. Okay, that's the basics. Now we gotta do some hard problems. I'm not kidding either. Do you need a little stretch break? I'm gonna plug on through. iPad? What'd you say?
No, I thought that was
Oh, no. So now we're gonna mix them. Now we're gonna do some composition functions. You'll be all right though. If you have a pretty decent grasp on that first section, this is just an extra little step. You'll be fine, okay? So here we go, composition of functions. There's different ways to evaluate these. I like to just kind of keep it simple, the simplest way to do them. Number 9. We're going to evaluate the sine of the arc sine of rad 2 over 2. Okay, you know composition of functions is like f of g of x, functions inside of functions. That's what a composition of a function is. So what you want to do is you want to work from the inside out, okay? Sometimes they're just going to be super easy answers, like you're going to get your answer right back. Sine and arc sine are inverse functions of one another. They kind of cancel each other out, but it doesn't always work that way. So let me show you. All right, so let's evaluate the inside. What is the arc sine of rad 2 over 2? That is pi over 4. The question is, what angle gives me rad 2 over 2? The answer to just the inside part is pi over 4. And now I need to evaluate the sine of pi over 4, which is rad 2 over 2. So in this case, my sine and my arc sine cancel it out. It's kind of like if I said, take a number and square root it and then square it, right? As long as the number's in the domain. All right, but it doesn't always work going the other way. So number 10. Let's see. Let's take the arc sine of the sine of 3 pi over 4. Okay, some people will just cancel out arc sine and sine and say my answer is 3 pi over 4, and that's incorrect. All right, so let's go ahead and let's evaluate this inside part first. What is the sine of 3 pi over 4? The sine of 3 pi over 4, if I go over here to 3 pi over 4, sine of that is rad 2 over 2, positive rad 2 over 2. Okay. So I'm in quadrant 2, remember, all saints trust Christ. So I'm in quadrant 2, sine is positive here. So the sine of 3 pi over 4 is rad 2 over 2. Now what's the arc sine of rad 2 over 2? Pi over 4. Okay, I can't get an arc sine and spits out 3 pi over 4. That's not going to work. Arc sine is only limited to quadrants 1 and 2. Okay? All right, number 11. Let's do the arc cosine of the cosine of negative pi over 3. Same thing here. These don't just simply cancel each other out. Okay? There's other ways to do this, though. I don't know if you like it this way, but what I would do is this. I would go to the cosine of negative pi over 3. So negative pi over 3 is down here. And I would evaluate this. I would start by evaluating the cosine of negative pi over 3. So what is the cosine of negative pi over 3? It's 1/2, right? 1/2. Now I need to find the arc cosine of 1/2. So that puts me back into quadrant 1 now, which would be positive pi over 3. That would be my answer. So you guys completely lost. You're very quiet. Do you not like these? I don't know. They're terrible? What's wrong? You want to try one on your own? See if you can get it? All right, cool. Thank you. All right, number 12. Let's do this one then. Let's do sine inverse of the sine of, let's do 7 pi over 6. Okay? 7 pi over 6. Here is pi over 6. It is, okay? So if you evaluate 7 pi over 6, you would go in the unit circle and you'd go to 7 pi over 6, and that's going to give you, oh wait, it's going to be negative pi over 6. Negative pi over 6, right? Yeah. This is going to give you a negative number here. It's going to give you negative 1/2, right? Mm-hmm. Because you're in quadrant 3. And sine is negative in quadrant 3. Wait, not 1/2. Rad 3 over 2. Sorry. There we go. All right. And then you evaluate sine inverse of negative rad 3 over 2 and you get negative pi over 6. You know your answer is going to be some kind of a pi over 6, okay? It's 1 over 2, isn't it? Yeah, it's 1 over 2. Okay. I was right. I'm like second guessing myself. 1 over 2. So pi over 6, this is rad 3 over 2, 1/2. Okay, so sine's 1/2. But I'm over here in quadrant 3, so my answer is negative 1/2. But when I evaluate the sine inverse of negative 1/2, I'm over here in quadrant 4, because that's where all my negative answers come from, and the answer would be negative pi over 6. Now, some people have a different way to do it. They think evaluating all that stuff is way too much work. They think of this like sine's going to give me the negative, and then the sine inverse would give me the negative pi over 6. Do you know what I mean? Like you get the negative answer, so you'll get negative pi over 6 as your answer. Okay, last part. What are we on, D? No, E. Sorry. I told you today was going to be a rough one. I did warn you. All right, so this one is going to be exact values. We're going to get away from the unit circle. Okay, I didn't spell values right. That would be good. Spelling counts all the time. So these ones, I don't know. I think you're going to be okay with these. So here we go. Number, what are we on, like 15, 100, 13. Number 13. We're going to evaluate the tangent of the arc cosine of 2/3. Okay? Now, as you know, 2/3 is not one of our special numbers that we keep seeing, these rad 3 over 2s, rad 2 over 2s, 1/2, stuff like that. This is not a unit circle problem. Okay? This is a totally different problem. It's going to be a problem where you're going to set up a right triangle. So this is what I want you to do. I want you to first start by letting inside of here equal some variable. The book likes to say it equals u. Okay? So all I did was I took this and I replaced it with u. And so what I'm trying to find really is the tangent of u. Okay? Trying to find out what the value of tangent of u is. So go up here to this step, and what you want to do is you want to take the cosine of both sides. Okay? So the cosine of u is equal to, now the arc cosine and the cosine are just going to simply cancel each other out, and you get 2/3. Is everyone following that? I went to this step right here, and I took the cosine of both sides. So now I know that the cosine of this angle u is 2/3. I need to find the tangent of u. So here's the part where I draw a triangle. And I label one of the angles U. And if I know that that's U, then cosine is going to be adjacent over hypotenuse. And my goal right here is to find the tangent of U. And tangent is opposite over adjacent, so I need to find out what that side is. What is that side? Rad 5. Perfect. So the tangent of U is going to be rad 5 over 2. And that's the answer. Pretty terrible? Or not? Yeah. No unit circle. You don't have to know, oh, which one. Is it 1/2 rad 3 over 2? I always get those mixed up. I've been teaching this thing for like 18 years, and I still get them mixed up. You think I'd memorize them by now? No. I have other things to do, like watch hockey. Okay, 14. Let's try another one of those. Another one. Cosine of the arc sine of negative 3/5. Now let me show you what happens when there's a negative. Okay? You have a different way to do this. I can see your brain working. It's scaring me. No. All right, so here's what I do. Here's what the book tells you to do. This is the way I've always learned it. It's to go U equals arc sine of negative 3/5. Okay? So really my goal, because I like to find out what am I actually looking for. I am trying to find out what the cosine of U is. That's going to be my answer. Okay? So let's go ahead and let's take the sine of both sides. So the sine of U and the sine of the arc sine. Well, the sine of the arc sine will cancel each other out, leaving me with the sine of U is negative 3/5. Okay. You're going to be over here in quadrant 4 because arc sine of a negative number gives you an answer in quadrant 4. So this is U right here. The sine of U is negative 3/5, which means opposite is negative 3. Hypotenuse is 5. Ooh, this is a nice one, huh? It's the good old 3, 4, 5 triangle. And this is positive 4. So your last step, like getting this answer, is to evaluate the cosine of U. Cosine of U is adjacent over hypotenuse. 4/5. That's your answer. 4/5. Okay, last problem of the day. Gotta go round number 15. What happens when they're not numbers? What happens when they're variables? Now this, yeah, you're like, why would they be variables? Well, because they're in calculus, they are. You're going to take derivatives of everything. You're going to take derivatives of, what's it called? The inverse functions. And you got to know how to do this problem. All right, sine of the arc cosine of x over 3. And your answer is going to be an algebraic expression in terms of x. You're not going to have a number answer like you did in the other ones. All right, it's the same idea though. It's exactly the same, you're just using letters instead of numbers. So our first step is to let U equal arc cosine of x over 3. So our goal is to evaluate the sine of U. I like to just kind of write that there. All right. Take the cosine of both sides. So the cosine of U is x over 3. We assume that all variables are positive, okay, on this, so you're actually just going to be in quadrant 1 for all of these. Gross. Quadrant 1. And here's U. And the cosine is adjacent over hypotenuse. And so what's this side over here? You got to use Pythagorean theorem. This is going to be the square root of 9 minus x squared. Never ever tell me that's 3 minus x. I will kick you out of here. I won't, but I'll be sad. Okay, so that's using Pythagorean theorem. And then now let's evaluate the sine of U. The sine of U is opposite, so rad 9 minus x squared over hypotenuse. That would be your answer. You do not need to rationalize. If that was switched and I was asking you for the cosecant and you got the radical on the bottom, you don't need to rationalize that.